welcome back to 4.5C. So I hope you guys got a chance to try to solve this equation. So let us see. We have a logarithmic term on the left hand side and one on the right hand side. So I bring both log terms on the left side and have the number, which was a -1 over here. I moved it to the right hand side. So this is what I started with. Now what can I do here? Use one of the laws of logarithm, and I can put it under single log term, and the right hand side is a number. So the next step is to write it, convert it to exponential form. Now some students do this, which is correct, by the way, that they will write the number over here as a base of the same, as a log of the same base which we have here. So this number is 1. So if the base is 9, what should come here? What should be here? So remember, log of a base a is 1. So I can write here 9. Okay. So now if you write it like this way, then actually we can apply that. So over here it will be log base 9 of 9. So you see there is one log term here and one log term on the left. So we can use the 1-to-1 property. But I did it a different way. Okay, so now looking at the next step, which is writing it as exponential form. So 9 raised to the power of 1, 9 is the base, this is the exponent, this is the quantity. So it gives me the equation, which is a quadratic one. So then I solve and I got x is equal to 6 or x is equal to -4. So when we check x is equal to 6, so the first term is log base 9 of x minus 5, and x is 6. So when I plug 6 in here, 6 minus 5 is 1, so I get log of 1 base 9 minus 1, which was here, equals negative of log of, so 6 plus 3 is 9, so log of 9 base 9. So I get 0 minus 1 is equal to -1, or -1 equal to -1, which is a correct equation, a correct statement. So it means x is equal to 6 will be our solution. Check the -4, and you notice that we end up getting log of -9. The first term looks like this, log of -9 minus 1 equals log of -1. Why -1? Because it is log of x plus 3. So our x is -4. So you get. Now if you actually do go from here, like if you keep going, so let me do it in red to just mark that it is not correct. So if someone goes like this, there was a negative sign here, so we make it positive, bring it to the left side, and you multiply this, use the product rule. So -9 into -1 is 9. So you get 1 is equal to 1. But you cannot do this because of the negative sign here inside the argument of the log. So that is not a solution. So the only solution is x is equal to 6. So that is why it is important to check. So x is equal to so solution x is equal to 6. Looking at the next one. So now we have two log terms on the left and two log terms on the right. I will just put them as single log term on the left and single log term on the right. So we can, because each one has a positive sign, so we can just multiply the arguments. So 3 times x plus 2. Then on this side log base 8 of 9 times 2x minus 1. Now use by the 1-to-1 property. You can now say 3x minus 6 equals 18x minus 99, and do your little algebra here, and we get x is equal to 7. Now we check and it satisfies, so we get solution x is equal to 7. Okay, so this is how we do the logarithmic equation. So in the next video, we will look at some exponential equations.